In this problem we have an ambulance going towards an observer. Now this ambulance, we're told, is going at 55 kilometers an hour and it's emitting a 640 hertz tone. So we want to know exactly what frequency does this guy hear. So when we set up Doppler shift problems, we always have to put the emitter here on the left-hand side and the person observing on the right-hand side. And we define positive as the normal right-hand direction. So that's the way we have to set all of them up for the way our formula is. So in this case, first we want to convert 55 kilometers an hour to meters per second. So we do everything in our standard meters per second units. Okay, so we multiply by the number of seconds in an hour first. So it's number of hours per second to make the units work. So we have 1 hour, and it's 3,600 seconds in an hour, times by number of meters in 1 kilometer, to cancel those units out. So we get a total of, this is moving at 15.27 meters per second. And the 7 is repeating, so that's why I put the dot above it, indicates it's repeating 15.27777. Okay, so now we just got to do our frequency Doppler shift formula. Observed frequency equals velocity of sound minus the observer's velocity, velocity of sound minus the source velocity, times the source frequency. So all we have to do now is solve for what we don't know, our observed frequency. And so we just got to plug in all of our knowns. Now, velocity of sound, if not given, is always assumed to be 343 meters per second. Okay, so we plug in what we don't know in here. 343 meters per second minus our observer velocity is 0. He's not moving. So we put in 0 divided by 343 meters per second minus our source velocity, which is 15.27 meters per second. So all of this in brackets multiplied by the source frequency of 640 hertz. Okay, so all we have to do is take 343 divided by this difference here, so we can see that our frequency will go up, which makes sense because this ambulance is moving towards us, so the sound waves will get compressed and closer together, so the frequency goes up. So that gives us a total, our answer is 660 hertz. Now it's 659, but I have to round to 2 significant digits because I only have 2 significant digits in these. That's your final answer.